Okay, so now we're going to actually apply the limit definition of the derivative at a point to an actual function. All right, so here in part A, I'm given that the function is equal to 2x plus 1. And so I want to know what the derivative is at x equals 2. Okay, so what's the derivative at x equals 2, or in other words, what's the instantaneous rate of change at x equals 2? Okay, so here I'm going to use this definition that it told me to use, because again, we know there's two definitions for finding the derivative at a point. All right, so we're going to use this definition. And so I'm going to say that in this case, I want to know the derivative at x equals 2. All right, so instead of using the derivative f prime, we call it for this like derivative, sorry, this little mark over here. You might hear us say this is f prime of 2. That just means the derivative at 2. The prime is for that little like tick mark here. Okay, so the derivative at x equals 2 is equal to the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Okay, so wherever you saw a in the formula, you want to just use 2 instead, because we're trying to find the derivative at 2 now, not at an arbitrary point a. Okay, so here, this is where you want to note to yourself what the heck even is f of 2 plus h. So let's jot that down over here. Okay, so what even is f of 2 plus h? Well, when you plug a number into the function, you replace x with your number, right? So wherever I see x, I would replace it with the number. It's the same thing for this expression, 2 plus h. Wherever you see x, you want to replace it with 2 plus h. Okay, and so you want to, whenever you evaluate or plug in a number into a function, or plug in an expression into a function, you want to use parentheses. So always use parentheses. Okay, and so here this is going to be 2, using parentheses now, plugging in 2 plus h, plus 1. And so now I want to distribute the 2, and so now I get that this is 4 plus 2h plus 1, which is equal to 5 plus 2h. Okay. And so you might also want to jot down, what is f of 2? That will just make our lives a lot easier here. So here, we'll figure out what f of 2 is. So f of 2 is just 2 times 2 plus 1, which is equal to 4 plus 1, which is equal to 5. Beautiful. Okay, so now going back to our limit. I have the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. So I'm just going to plug in what I just found, highlighted in red and stuff, into this. So I have the limit as h approaches 0 of 5 plus 2h minus 5 all over h. Okay, and so now let's simplify the numerator. So the 5's cancel, and so what I'm left with in the numerator is 2h over h. And so you notice here also that these h's cancel. And so now I have this as just the limit as h approaches 0 of 2. And so what did we say that the limit of a number was? It's just that number. And so I have that the derivative at 2 of this function is just 2.